Hello everyone, welcome back to my channel. Here I will calculate partial pressure, average molecular weight and mixture density step by step using ideal gas law. Here is the problem statement. An ideal gas mixture at 30 degrees Celsius and 2 atm contains 30% methane, 50% ethane and 20% propane, all by volume. Since this is an ideal gas mixture, the mole fraction equals the volume fraction. So we can write mole fraction equals volume fraction. Now here given data's temperature is given, that is 30 degrees centigrade. So now if we can convert 30 degrees centigrade to Kelvin, so 303.15 Kelvin. Total pressure P is equal to 2 atm. Here I'll find three things. So one is partial pressure of each gas component, 2 the average molecular weight of the gas mixture, and 3 the mixture density by using ideal gas law. Now step 1, that is partial pressure of each component. Now here the mixture is ideal gas mixture. The partial pressure of a component I is proportional to its mole fraction or volume fraction. So we can write Pi is equal to Yi. Yi is the mole fraction into P total. Now here the given data is already I talked about. Temperature is 303.15 Kelvin and P total is 2 atm. Now here mole fraction, as that in that problem that volume percent is given, so or volume percent is equal to mole percent. So from here and there I can easily write that mole fraction. So methane mole fraction is 0.3, ethane mole fraction is 0.5 and propane mole fraction is 0.2. And molecular weight of the methane is 16.04, then ethane molecular weight 30.07 and propane molecular weight is 44.10. Now here I am going to calculate the partial pressure. Now we already know that partial pressure is equal to mole fraction into total pressure. Now for methane mole fraction we know that is 0.30 into 2, so that is 0.6 atm. Ethane, that is mole fraction is 0.5 into 2, so that is 1 atm. And that propane mole fraction is 0.2 into 2, so that is 0.4 atm. And we know that P total is equal to summation of partial pressure. So here that partial pressure of methane is 0.6 and then partial pressure of ethane is 1 and partial pressure of then propane is 0.4, so that is 2 atm. So we know that P total is also 2 atm. Now we have to calculate second that question, that is average molecular weight. Now here that mi is the molecular weight of each component. So that let mi be the molecular weight of component I. So we know already that component methane molecular weight is 16.04, that ethane molecular weight 30.07 and propane 44.10, and average molecular weight we know that is summation of yi into mi. Now here the average molecular weight by the mixture, so that is m bar is equal to yi mi. So that is methane mole fraction into molecular weight, then ethyl mole fraction into molecular weight, and then propane mole fraction into molecular weight. So now if I do the calculation, so each term we are calculating here. So if we add all this, so molecular weight, average molecular weight will be 28.667 gram per mole. Now next I am going to calculate the mixture density. So here we will use ideal gas law. So that is for ideal gas law we know that PV is equal to nRT. So here that for 1 mole gas V is equal to nRT by P. So here N is actually 1. Now for mixture density is that P sorry, rho is equal to P, that average molecular weight, by T. So now here R is equal to 0.0821 liter ATM mole, uh, mole inverse, that Kelvin inverse. So other data we know, R we know, P is given 2 atm, T is 303.15, that is given, and average molecular weight we already calculated, that is 28.667 gram per mole. So from there, from all this data we can plug that and we calculate the rho is equal to 2, that is pressure, then average molecular weight, then R value, and then temperature. So if we do the calculation, we'll get that rho is nothing but 2.30 gram per liter. So now equivalently, so if I convert to kg per meter cube, so that will be 2.30 kg per meter cube. So now here is the final answer. So partial pressure of methane 0.6 atm, partial pressure of ethane 1 atm, partial pressure of propane 0.4 atm, average molecular weight is 28.667 gram per mole, and rho is 2.30 gram per mole. Now here I have wrote that Python code for these total things, and if we run that, so we'll get same kind of things. So here ideal gas mixture property, so component methane, ethane, propane, then mole fraction already given in the problem, 0.3, 0.5, 0.2, molecular weight we know, that is 16.04, 13.07, 14, 44.10. Now partial pressure we can calculate, already calculated in that problem, that is 0.6, ethane is 1 and propane is 0.4. Average molecular weight we have calculated, that is 28.667, and mixture density 2.304. So now here this is the code. If you want to do Python programming, so you can do that and you can run in Colab. So that's way we can solve this problem, and we got the answer. Okay, so this is the final answer. That's it. Thank you.